Hi everyone, it is the mini course from EDCI 339, and today's topic is group theory from abstract algebra. You might be wondering why I choose this topic and what is this about? Is it useful? Or you can ask, what is the application of this subject? Firstly, there's some background about the group theory. The group theory is firstly generated by Cauchy and Palois. Cauchy and Palois are both from French, and Cauchy is an ethicist. Palois is not only major in mathematics, but also have a great achievement in the philosophy area. Then the application the group theory. The group theory is mainly used as an important tool. For example, the modern particle physics would not exist without group theory. And also, crystals and a hydrogen atom can be modeled by the symmetry groups. Then, what is a group? To know what is a group, we first need to know the definition of the group. There are four requirements, or you can say four conditions for being in a group. The first one is a group G is a non-empty set G. It means that there's a set G is not empty, means there must be something in the set. Then this is the first thing we need to prove. The second one is it will close on the group operation. For here, the group operation is pretty similar to the regular algebra, either multiplication or addition. That means either multiplication and addition will close under the group operation. The third one is the identity. To prove that a set is a group, we need to prove the identity is closed under the group. And what is the identity? The definition of the identity is there's one element E times any elements in the group. It will be the element itself. Then the element E is the identity. To represent as an equation, we can say E times A equals to A itself, and A times E will also equals to A itself. Then E is the identity. The last one is the inverse. The definition of inverse is any element inverse, let's say A to the power of -1 times the element itself, let's say A, will equal to the identity. Then the inverse is A to the power of -1, and A to the power of -1 must close under the group. To represent as an equation, we can say A times A to the power of -1 will equal to identity, and A to the power of -1 times A will equal to identity. After you prove all these four conditions, we can say the set G is a group. Now we can see one example. The set of all real number x such that x greater or equal to 1 with operation multiplication. Remember what I said before? The first thing we need to prove is we need to prove the set is not empty. As the question says, all real number x such that x equal or greater than 1, which means there's an infinity number of elements in this set, which means the set is definitely not empty. So not empty, check. The second one is the identity. We first need to know what is the identity of this set. The definition says the identity times any elements in this group and will be equal to the element itself. As you may already know, the identity of this set is 1, because 1 times any elements in this set will be the element itself. For example, 1 times 2 equals to 2, 1 times 3 equals to 3. Is it 1 close under the group? Yeah, for sure. The question says x is greater equal to 1 or equal to 1, and 1 is definitely another group, so identity is checked. So the definition of inverse is any element inverse times element itself will equal to identity, which is 1 in this example. For example, let's say x equal to 2, and what elements times 2 will be equal to the identity, which is 1 in this example, 1 over 2. Is 1 over 2 are all closed under the group? No, because the question has already mentioned that x must equal or greater than 1. So 1 of 2 is not closed under the group. So the inverse is not closed under the group. So we can say this set is not a group. As I mentioned, the operation of the group is pretty similar to the regular algebra, addition and multiplication, and there's really nothing much we can talk about it. The last but not least is there are several different kinds of groups, and I will introduce all different kinds of groups. However, there will be lots of work to be done if you need to know each of these single groups. So for here, I will generate introduce of these groups, and there will be cyclic group, dihedral group, alternate group, symmetry group, and claim group. If you are really interested in abstract algebra and you want to know more about these groups, there's a free source online which is Abstract Algebra Theory and Application, and I have already posted the website on the bottom of this page. So for conclusion in this course, we firstly talk about some history, the background of the group theory. Then we talk about the application. After that, we know how to determine the group, and this will definitely include the definition and operation. The last but not least, they introduced several different kinds of the group. And that's everything of this course, and thank you very much.